Okay, so we're going to share our screen. We're going to work on the skill building section and give you some examples of the skill building section of amazing area mazes. So here we are, and so we've done the warm-up. So we've done the warm-ups and you're ready for more. Let's just look at some of these problems here. So you can see that some people can do them very rapidly, but don't worry about it. It's not about speed, it's about just developing your skills. And so as we look at this one, we say, well, sorry, I don't say that. Make it a little bit bigger. And you think, well, what would that first step be? And we're going to work our way down to finding out this unknown. So we have an area of 15 and we have the width of 5. So the height is 3. Okay. Now using the 3 and the 4, so we say 3 plus 4 equals 7. So we have the height of the next rectangle is 7. Area is 35. So this is a 5. Now we put together the 5 and the 3 to get 8. 8 goes into 32 4 times. So then this is a 4. 4 plus 5 is 9. 9 times 6 is 54. And so when you look at that, you see how we just worked our way down. 5 times 3 is 15. Then the 3 here got added to the 4, so we got the height of the next rectangle, and then we got its width. We added the 2 widths, the 5 and the 3 together to get the width of the one underneath. Found the height of 4, then used the 4 plus the 5 to get the height of 9. That height of 9 went into 54 6 times. Okay, so a nice logical progression there. Okay, so if we look at number 9, so again, say, well, I got to get to over here to this question mark. And normally you're going to go from as far away. So in this case, we'll be going from this end over that way. They could be tricking us, but normally that's the kindly way they do it, is they sort of have you go in a progression. So we look at this and we say, they're giving me this whole distance of 12, but maybe I'm going to subtract and get the other one. Okay, so we've got 3 and 21, so 7 goes into that. 7 times 3 is 21. So that would mean that this is 12 minus 7 equals 5. So we've got a 5 here. So 5 goes into 35 7 times. So then this one is 11 minus 7 equals 4. So this is 4. Okay, so now when we look at this, we say, I'm not exactly sure. 4 doesn't go into 30 an even number of times. Okay, and so as you look at it, you think, well, what can I do here? Well, it turns out you don't have to figure this one out. So as you're looking at it, you think, oh, I'm stymied. But in fact, you say, well, that's also 4 up here. And so we just need the 4. We don't need to figure out this height. Okay, so notice how, in looking at it, you think, oh, I don't know what to do here. But then you say this is 10 minus 6. 10 minus 4 equals 6. So this one is a 6. So 6 here and here. So then this height is 5. This is 12 minus 5 equals 7. Okay, so now we multiply 4 times 7 and we get 28. Go to the next one. And again, we say, well, what are we trying to find out? We're trying to find out this bottom. And maybe we're going to end up adding the 2 pieces to get it. So we look at what we know. So we say the first thing we could figure out is that this is a 4. Okay? That's a 4. Then now we know that this is a 4. Okay, so now we have this bottom is a 3 and a 4. So together it's a 7. So it makes the height of this a 3. And so we put the 3 and the 4 together, that's 7. 7 times 3 is 21. Okay, so we've got one of the pieces that we need. But we've got to get this whole length here. So you don't just guess and say, oh, I think it's 5 times 7. I can get it from that. So you don't want to do that. But what else can you do? Now, so let's see what else we can do here. And so as you look at it, you can see it, that it's not as obvious. And you think, well, so now you're saying, well, I wonder if there's a relationship between this area, okay, and the area of this bigger rectangle. So if I put that in red, I say, well, I've got this big rectangle here. And so this big rectangle is 12 plus 16 plus 21. So let's see, that would be 49. That equals 49. Okay, and you know, it makes sense, right? Is that we've got 7 here and 7 here. So we've got 49. But and you know, now when I thought of that, so you see, I was just kind of poking around, but I said, well, wait a minute, I actually knew that this was 7, right? So that means that that is 7 as well. So it turns out from the 49, we could have figured out with proportions, but we don't need to. The 7, we find the 7 over here. So there's the 5. So you can see I'm not the optimal solver of these as well. But I kept going at it and I found the answer. So let's try 20. So 20, we're trying to get over to that rectangle area, that rectangle there in gray. And so we say 5 goes into 24 times. Okay, and so the 4 up here allows us to do this as 10 minus 4 equals 6. So we've got 6. So our whole guy here is 9. So the whole guy here is 9. But remember, that means that, so if this height is 9, then what else can we get from that? Well, so if we know that this is 6, then we know that this is 9 minus 6 equals 3. So this height is 3 here. Okay, so then you say, well, I just need to get this base. But if I know this is 11, I just need to find out what this base is of this tall rectangle. And I know that this is 9, right? I figured out that that was 9. And so then this is 9 goes into 36 4 times. Okay, so now I've got, well, then this guy is 11 minus 4 equals 7. And so together, this one equals 7 times 6 equals 42. Okay, so that one wasn't so bad either. Okay, so now let's look at 30. Okay, so in 30, you can see we've got a bunch of pieces that we're going to put together to get the width and the height of that one. Okay, so we start and we say, well, here we go, 5 inches, 35, that's a 7. So we already know one side, we know the 7. And so that seems pretty easy, right? And so you think, well, there must be something hard about this, right? And so if we know the 7 there, and then we say, well, this is 3, so then this is a 4. And so now we say, well, gosh, if we could figure out that this was, well, what about this one, right? So you say, well, I know that because 16, 4 goes into 16 4 times. So you got 4 there. So now we've got this whole thing as being a 4 and 3, a 7 by 7. So we've got this 7 by 7 and 49 inches. Okay, so we've got 7 here. So 7 here means that this height is 6. If that height is 6, then this height is 3. But then 3 goes into 12 4 times. So then this whole distance is 4 plus 3 equals 7. And we've just got another 49 here. So this is 7 times 7 equals 49. So that one wasn't so bad either. Okay, let's see what happens in 40 if that gets to be a more difficult one. Okay, and so a lot of times so where's the first thing I can get? So it looks like there's a couple ones we can get right away. So 24 with a width of 8 has a height of 3. And 16 with a width of 4 has a height of 4. So 4 and 3. And okay, so then let's add up the 2 and the 4 together. So this is 2 plus 4 equals 6. 6. So this is 3. And so you say, well, I wonder if that's going to help me. And you're not sure initially if it's going to help you or not. Just kind of stride ahead, hopefully. And then you ask yourself, what about this 6 up there? Well, do we have the height of the whole thing? So we do, right? So we know that they have a 3 and a 4. So the height of this combined thing, 3 and 4, is 7. Okay, so then that helps you say, well, if this whole thing is 7, so this whole thing is 7, then this is 3 and this is 4. And but if this part is 4, then that base must be 3. Okay, but if the base is 3, then up here is also 3, and that means that this guy here is 6 minus 3 equals 3. And so we've got 3 times 7, 21. So notice that took a little bit of work. Yeah, let's look at the next one. At number 50. Okay, so again, we say working our way down to the question mark. Got a 9 here, so you get the fraction multiplication tables. So this is a 9 as well. And a little bit harder here, right? So there's not much to go on, but what you can go on is this. So you notice how they have the same width. So that 54-inch and these two guys. So say, well, I'm going to think of this as a single rectangle. Well, how much is that single rectangle? So it's 15 plus 21 equals 36. Okay, so now just take a look at that. So you've got the same base, but it's got 54 and 36. So what's the relationship? Well, it's a 3-to-2 relationship, right? It's a 3-to-2 relationship in area. Well, if you've got the same base, then that means you must have a 3-to-2 relationship of your heights, or 6-to-4. Okay, so that's a little bit more work than we've been doing in the previous puzzles. Okay? So we say, okay, I've got this relationship 54 to 36. Okay, so whatever that, so and there's the base is 9, right? So 9 times 6, well then to get this one, it must be 9 times 4. 9 times 4. Well, it turns out that you could have just added up and multiplied, but it's nice to look at that relationship as well. All right, so now you say, well, there's no way I can get something from this 17, is there? Okay, well, there isn't, but then you can do something clever. Okay, so let's do something clever here. So let's say, all right, we got something by adding up 15 and 21. Let's try to add up 15 and 17. So 15 plus 17 equals 32. And remember, over here we found that this was a 4. So 4 times what equals 32? 4 times 8. So, oh, this is an 8. Okay? And now we've got our solution. So what goes into 40? 8 goes into 45 times. Okay, so when you think about that, right, so you combine 15 and 21 to get 36. And then that helped you to figure out that this was 4. 9 times 4 is 36. And then you combine 15 and 17 to get 32. 4 times 8 is 32, and multiply. So that's a very nice one. Okay, and this last one, okay, I don't think I've got time to finish this video, so I'm going to leave it for later. But I will stop this video now, because I've got a class in 3 minutes. I don't think I can do